There are three ocean current branches that transport warm Atlantic water into the Arctic Mediterranean, from where it spreads throughout the Arctic region, carrying along heat. This talk focuses on one of these branches, the Faroe Current, which flows between Iceland and Faroes. This is the main branch, carrying almost half the volume transport. The Atlantic inflow between Iceland and Faroes crosses in a wide region where it would be difficult to monitor, but fortunately it's focused into a narrow boundary current north of the Faroes, and there we have monitored it now for more than 2 decades. The monitoring section has the warm Atlantic water on top and in the southern part. Below that there is cold water from various Arctic regions. So to monitor transport we need several parameters. We need the velocity field. We also need to know the boundary between the Atlantic water and the Arctic waters, and we need the temperature of the Atlantic water. Now, as I said, we have been monitoring this for a long time with our research vessel and with moored equipment, especially ADCPs that monitor the velocity field. We've had a lot of ADCPs in this region. The problem is that these in situ observations are very expensive and hard to maintain, so how much of this can be replaced by satellite altimetry? To answer that question, we have been correlating our long-term in situ observations with satellite observations, and here we focus on monthly averages. Now, there is a problem that satellite altimetry gives surface velocity averaged between altimetry grid points, whereas the ADCPs give local velocity. But if you combine the velocity from several ADCPs to also give horizontal average, the correlation is very high. So altimetry derived variations of the surface velocities are good, but not the absolute velocities, probably because the geoid is too smooth in this region. But since we have the in situ observations, we can calibrate the altimetry and thus get highly accurate surface velocities. Of course, to get volume transport, you need to integrate the velocity. But we find from the in situ observations that there are high correlations between surface and subsurface velocities, which means that there is a high correlation between surface velocity and vertically integrated velocity, down to the average boundary. The boundary is not fixed to its average location, but from the observations we find that its movements follow the surface movements fairly well. This is called Geostrophic Adjustment. And so when we combine all this, once calibrated by in situ observations, monthly volume transport of the Faroe current may be determined from satellite altimetry alone, although we get higher accuracy if we have a few in situ observations. If we want to have heat transport, then we must have in situ observations, especially temperature. But fortunately, we do have that for quite a long time, and so we can reconstruct the heat transport of the Faroe current back to 1993. So bottom line, we still need in situ observations, but much less and so much cheaper. Some literature and thank you to the Blue Action Project, which has funded the conclusion of this.